Can you imagine if NASA, the agency that took us to the moon, that built the space shuttles, stopped building its own rockets forever? This isn't science fiction. It's the heart of a silent battle, a fight for the very soul of space exploration that's being waged right now, in the halls of power, in leaked reports, and in the mind of a man who could change everything. Welcome to the next framework in engineering. On this channel, we don't just observe the present. We're here to unravel the blueprints of tomorrow. Our mission is to give you the foundations, the fundamental knowledge of today's engineering, so that together we can build the future with a tool that is redefining everything, artificial intelligence. And the story we're going to analyze today is perhaps the most spectacular example of this transition. It's the story of a plan called Project Athena and its architect, Jared Isaacman. To understand the magnitude of what's at stake, we have to understand who Isaacman is. He's not a career bureaucrat. He's a tech magnate, an accomplished pilot, and most importantly, an astronaut. But not a NASA astronaut. Isaacman has commanded 2 private space missions. The first, Inspiration 4, was the first orbital flight in history crewed exclusively by civilians. The second, Polaris Dawn, broke the record for the highest Earth orbit since the Apollo era and conducted the first ever commercial spacewalk. This man doesn't just talk about space, he has lived it from the front lines of the commercial revolution led by companies like SpaceX, of which he's a close partner. And it is precisely this experience that shapes his radical vision for NASA. In late 2025, amidst a massive political storm, with old guard aerospace lobbies pulling strings and tensions within the White House itself, a document is leaked, a plan of over 100 pages known internally as Project Athena. It's Isaacman's roadmap for the agency, and its central proposal is a seismic shift. NASA must stop being a rocket builder. Think about it. For decades, the iconic image of NASA has been its rockets, the Saturn V, the Space Shuttle, and more recently, the SLS, the Space Launch System. The SLS is an engineering behemoth, a colossus that has cost over $100 billion over 20 years. It's a testament to a nation's industrial power. But according to Isaacman, it's also an anachronism. It's the past, a system that is incredibly expensive per launch, with limited reusability, and based on decades-old technology. Meanwhile, the private sector, with SpaceX's Starship leading the way, is building fully reusable systems at a fraction of the cost. Isaacman's philosophy is simple and brutally logical. Why should the government spend billions of dollars building something that the private industry can already do better, faster, and cheaper? Access to low Earth orbit, that first step into the cosmos, has now been commercialized. NASA, he argues, must not duplicate efforts. Its value, its true essence, lies elsewhere, in pursuing the challenges that no one else dares to touch, the nearly impossible. And this is where Project Athena begins to sketch out the future. It is articulated around 5 fundamental priorities that together not only redesign an agency, but propose a new paradigm for space exploration. First, Isaacman wants to reorganize and empower. This might sound like corporate jargon, but in the context of NASA, it's a revolution. He proposes a single, data-driven reorganization to eliminate the layers upon layers of bureaucracy that separate the leaders from those who actually do the work, the engineers, the scientists, the technicians. He wants to free up the budget from obsolete infrastructures and reignite a culture where it's understood that on the frontier of knowledge, some risks are worth taking. He wants the agency to be agile, fast, and bold again. The second pillar is to reassert American leadership in what he calls the high ground of space. This means, of course, fulfilling the promise of the Artemis program, returning to the moon and establishing a sustainable presence there. But the crucial part is what comes next. Once the lunar architecture is affordable and repeatable, thanks to commercial partners, Isaacman proposes that NASA shift its resources towards those frontier technologies that today seem like they're straight out of a novel. We're talking about nuclear electric propulsion, the holy grail for rapid transit to Mars. We're talking about active cooling of cryogenic propellants in deep space, about new ways of generating power on the lunar surface, technologies that no private company will develop on its own because the return on investment is too far in the future, but which are absolutely indispensable for humanity's next great leap. The third priority is a pragmatic but vital challenge: solving orbital economics. Isaacman understands that the future of commercial space stations, those that will replace the International Space Station, depends on a simple question: is it profitable? His plan calls for NASA to act as a catalyst, not only by maximizing the life of the ISS, but also by streamlining the processes for science and research to get to orbit faster. And most importantly, he wants to actively partner with industries like pharmaceuticals, biotechnology, or even mining to figure out how we can extract more value from space than we invest in getting there. He wants to answer the question of how we're going to fund the future we all dream of. The fourth point is, for me, one of the most fascinating, and it transforms NASA into a force multiplier for science. For decades, planetary science has been dominated by gigantic, multi-billion-dollar missions that take decades to develop. If they fail, the blow is devastating for an entire generation of scientists. Isaacman proposes a radical change in philosophy, inspired by the successful CLPS program for commercial lunar payloads. The idea is simple. Instead of a single billion-dollar mission, why not launch 10 $100 million missions? It's better, he argues, to accept that some of them might fail in exchange for higher frequency, more opportunities, and a much faster pace of discovery.
Thanks, Anna. This approach extends to Earth observation. Instead of NASA custom building every single one of its satellites, why not just buy the data from the commercial constellations that already exist and are imaging the planet every day? Freeing up those funds would allow for even more planetary science missions, more probes to Jupiter, more rovers on Mars, more telescopes searching for the secrets of the universe. It's a mindset shift from doing everything to enabling everything, using NASA's resources in the smartest way possible. And this brings us to the fifth and final pillar, the one that connects directly to the heart of this channel, investing in the future. This is where Isaacman lays the groundwork for the operational and technological infrastructure of the new space age. He proposes creating a Starfleet Academy, an institution where NASA would train and certify the commercial industry to operate safely in space, passing on its immense operational knowledge. He envisions consolidating all mission control into a single nerve center, a kind of NORAD for peaceful space, capable of simultaneously overseeing dozens of missions, both governmental and commercial. But among these crucial investments, he explicitly mentions three elements: replacing obsolete IT systems, methods to alleviate the demand on the Deep Space Network, and of course, artificial intelligence. And I want us to pause here because this is not a minor detail. It's the key that ties the entire plan together. The Deep Space Network, or DSN, is the system of giant radio antennas spread across the globe in Spain, Australia, and California that allows us to communicate with our probes on Mars, with the Voyager at the edge of the solar system, with the James Webb Telescope. It is our ears and our voice in the cosmos. Now imagine that network as an air traffic controller, but for the entire solar system. As we launch more and more missions, more satellites, more rovers, that controller gets saturated. Every mission competes for precious antenna time. The DSN has become a bottleneck for our ambitions. If we want a future with 10 science missions instead of one, with a permanent lunar base, and with preparations to go to Mars, we need to solve this problem. And the solution isn't just to build more antennas, it's to make the network smarter. This is where artificial intelligence comes into play, not as an abstract concept, but as a fundamental engineering tool. AI is what can optimize the DSN in ways that are impossible today. An AI system can manage the communication schedule dynamically, allocating bandwidth in real time based on each mission's priority, atmospheric conditions, or the position of the spacecraft. It can predict failures before they happen and optimize data transmission by intelligently compressing information on the probe itself before sending it, so that only the essential data reaches us. But it goes even further. AI can give our spacecraft greater autonomy. A probe equipped with AI could analyze a rock formation on Mars on its own and decide, without waiting for commands from Earth that take minutes to arrive, that it's worth taking a sample or performing a more detailed analysis. This not only eases the burden on the DSN, but also accelerates the pace of discovery exponentially. AI becomes the intelligent co-pilot for every mission. Therefore, when Isaacman talks about investing in AI, he isn't just using a buzzword. He positions it as an operational pillar, as crucial as nuclear propulsion or the Astronaut Academy. It's the software that will allow all the hardware of his grand vision to function. It's the foundation of the next framework in engineering, where intelligent data management and autonomy become just as important as the power of the engines. This entire plan, of course, has been met with fierce resistance. The lobby of traditional contractors, accustomed to cost-plus contracts where delays are rewarded with more money, see Isaacman as an existential threat. Politicians and analysts warn about the risk of NASA losing its own technical expertise by relying too heavily on the private sector. The leak of Project Athena was in itself a political warfare, an attempt to use the plan's most controversial parts to sink his nomination. But what this battle reveals is that we are at an inflection point. The old way of exploring space, slow, bureaucratic, and extraordinarily expensive, is clashing with a new model, agile, competitive, based on public-private partnership, and powered by technologies like artificial intelligence. Jared Isaacman's vision, embodied in Project Athena, is much more than a management plan for a government agency. It is a manifesto. It is the declaration that NASA's role is no longer to build the highway to the stars, but to be the architect who designed the impossible destinations waiting for us at the end of that highway, providing the technologies and the vision that only it can create. It's a future where NASA focuses on getting us to Mars with nuclear propulsion while commercial companies handle transport to the moon. A future where hundreds of low-cost science missions populate the solar system, making autonomous decisions thanks to AI and sending back only the most amazing discoveries. It's a future that is risky, bold, and above all, exciting. And it's exactly the kind of transformation we explore here at the Next Framework in Engineering, because understanding how a plan like Athena seeks to dismantle old structures to build something new, and how AI is the mortar that binds all the pieces of that new edifice together, is fundamental. It's about knowing the present of engineering so we can actively start building the future. Thank you for joining us on this journey. See you in the next one.